Time is one of the most enigmatic and intriguing aspects of our universe. A time paradox is a situation where the laws of time lead to a contradiction or a logical inconsistency. Imagine, for instance, you travel back in time and prevent your grandparents from meeting. This would mean you never existed to go back in time in the first place. This is known as the grandfather paradox. Time paradoxes challenge our understanding of reality and how events unfold. They force us to question the linear conception of time, where the past influences the present, which in turn shapes the future. Instead, paradoxes suggest that the relationship between different points in time might be far more complex. Exploring time paradoxes helps us delve into the very nature of time itself. Are past, present, and future distinct entities, or do they coexist in some mysterious way? These questions are essential for both scientists and philosophers who seek to understand the universe and our place within it. In this essay, we will explore various theories and ideas about time. We'll see how scientific principles such as the theory of relativity and quantum mechanics influence our perception of time. We will also discuss the block universe theory and time travel, ultimately pondering whether the future has, in some sense, already happened. Albert Einstein's theory of relativity revolutionized our understanding of time. According to this theory, time is not a constant, unchanging entity. Instead, it's relative and can vary depending on speed and gravity. This means that time can slow down or speed up based on how fast an object is moving or how strong the gravitational field is. Einstein's famous equation E = mc2 shows that time and space are intertwined in what we call space-time. This unification implies that events are not just positioned in three-dimensional space, but also have a temporal dimension. As a result, two observers moving at different speeds may perceive the timing of events differently. One of the most fascinating implications of the theory of relativity is time dilation. For instance, astronauts traveling at speeds close to the speed of light would age more slowly compared to people on Earth. This concept has been confirmed by experiments using precise atomic clocks placed on fast-moving aircraft. Understanding relativity helps us grasp how time can be flexible and dynamic. It challenges the traditional notion of time as a fixed background against which events occur, opening up possibilities for different interpretations of past, present, and future. Time travel has long been a staple of science fiction, but could it be possible in reality? According to some scientific theories, the answer might be yes. The concept of wormholes, which are hypothetical tunnels connecting different points in space-time, suggests a potential method for traveling through time. Wormholes, predicted by Einstein's general theory of relativity, could theoretically allow for shortcuts between distant parts of the universe. If one end of a wormhole is accelerated to near light speed and then brought back, it might create a time difference between the two ends. This could potentially allow travel between different times. Another intriguing idea is the concept of closed timelike curves, or CTCs. These are paths through space-time that loop back on themselves, theoretically enabling an object to return to its own past. While these ideas are mathematically plausible, they face significant practical and paradoxical challenges. For instance, the grandfather paradox mentioned earlier poses a significant problem for time travel logic. If you could travel back and change events, it might create contradictions that defy our current understanding of causality. Scientists and philosophers continue to debate whether these paradoxes make time travel impossible, or if there might be unknown mechanisms that could resolve them. The grandfather paradox is one of the most famous and perplexing time paradoxes. It raises essential questions about causality and the nature of time. Imagine you go back in time and accidentally prevent your grandfather from meeting your grandmother. This action would mean your parents, and consequently you, would never have been born. If you were never born, you couldn't exist to go back in time and prevent your grandfather's meeting. This creates a logical inconsistency, challenging the very possibility of time travel. This paradox highlights the potential problems with altering the past and the complex interplay between cause and effect. Some theories suggest that the universe might prevent such paradoxes from occurring. One idea is the Novikov self-consistency principle, which posits that any actions taken by a time traveler were already part of history and thus cannot change it. Another theory involves parallel universes where each timeline alteration creates a new separate universe, avoiding contradictions. The grandfather paradox remains a staple of discussions about time travel. It serves as a crucial point of reflection for scientists and philosophers who seek to understand the implications of moving through time. While solutions to the paradox are still speculative, they drive the ongoing exploration of time's mysteries. Section 5. The Block Universe. Theory, past, present, and future coexisting. The block universe theory offers a radical perspective on time. According to this theory, time is like a block extending across the past, present, and future. All moments in time exist simultaneously, much like different locations in space. This view suggests that the future is as real and fixed as the past and present. In a block universe, the flow of time is an illusion. We perceive time as passing because of our consciousness moving through different moments. However, in reality, all moments exist together in a four-dimensional space-time block. This idea aligns with Einstein's theory of relativity, where time is a dimension similar to space. One fascinating aspect of the block universe is that it implies determinism. If the future already exists, then every event is predetermined, challenging our notions of free will and choice. This can be a difficult concept to accept, as it suggests that our sense of making decisions is merely a perception rather than a reality. The block universe theory provides a framework for understanding how past, present, and future might coexist. It challenges our everyday experience of time and invites us to reconsider what it means for events to occur. While this theory is still debated, it offers a thought-provoking perspective on the nature of time. Section 6. Quantum mechanics and time, the uncertainty principle. Quantum mechanics introduces another layer of complexity to our understanding of time. At the quantum level, particles behave in ways that defy classical logic. One of the key principles in quantum mechanics is the uncertainty principle, which states that certain pairs of properties, like position and momentum, cannot be precisely measured simultaneously. This principle has profound implications for time. It suggests that at the smallest scales, time might not flow smoothly. Instead, it could be subject to fluctuations and uncertainties. This challenges the classical view of a well-defined continuous timeline and introduces the idea of probabilistic events. Quantum entanglement further complicates our understanding of time. When two particles become entangled, their states are linked, no matter how far apart they are. A change in one particle's state instantly affects the other. This phenomenon seems to transcend the conventional limits of time and space, suggesting a deeper, interconnected reality. Quantum mechanics forces us to rethink the nature of time and causality. It opens up possibilities for non-linear time, where cause and effect might not follow straightforward paths. This adds another dimension to the discussion of whether the future has already happened, as it implies that our current understanding of time might be incomplete. Section 7. Philosophical perspectives on time. Philosophers have long debated the nature of time, adding rich perspectives to scientific discussions. One key debate is between presentism and eternalism. Presentism holds that only the present moment is real, with the past gone and the future not yet existing. Eternalism, on the other hand, aligns with the block universe theory, suggesting that all points in time are equally real. Philosophical inquiries into time often delve into the human experience of temporal flow. Why do we perceive time as moving forward? Some philosophers argue that this perception is tied to our psychological processes and memory. Others suggest that the arrow of time, marked by increasing entropy, shapes our experience of past, present, and future. Existentialist perspectives, like those of Martin Heidegger, explore how our awareness of time impacts our existence. Heidegger argued that human life is fundamentally temporal, with our future-oriented goals and past experiences shaping our present actions. This view emphasizes the subjective nature of time and its central role in human existence. Philosophy provides a valuable lens through which to examine time. It encourages us to question our assumptions and consider multiple dimensions of temporal experience. By integrating philosophical insights with scientific theories, we can develop a more nuanced understanding of time's mysteries. Section 8. Everyday implications of time paradoxes. Time paradoxes aren't just abstract concepts. They can influence our daily lives and how we perceive reality. Consider the idea of déjà vu, the feeling that we've experienced something before. Some theories suggest this could be related to minor time anomalies or the brain processing information in a way that momentarily disrupts our sense of temporal flow. Our understanding of time also affects how we plan and make decisions. If the future is predetermined, as some theories suggest, It could influence how we approach goal setting and life choices. However, most people operate under the assumption that the future is malleable and shaped by our actions. Time management is another practical aspect influenced by our perception of time. Techniques like mindfulness and time chunking help us navigate the present moment more effectively. These practices can be seen as ways to align our subjective experience of time with our goals and responsibilities. Cultural attitudes toward time vary widely. In some cultures, time is viewed as a linear progression, emphasizing punctuality and schedules. In others, time is more fluid, with a focus on events and relationships rather than strict timelines. These cultural differences highlight the diverse ways in which humans experience and interpret time. Section 9. Conclusion. The enigmatic nature of time. Time remains one of the most profound mysteries of our universe. From scientific theories like relativity and quantum mechanics to philosophical debates and everyday experiences, our understanding of time is complex and multifaceted. The idea that the future might already exist alongside the past and present challenges our conventional notions of temporality. Time paradoxes like the grandfather paradox force us to reconsider the linear flow of time. Theories like the block universe suggest a more intricate reality. Quantum mechanics introduces uncertainty and interconnectedness. Ultimately, the nature of time invites endless curiosity and exploration. We continue to seek a deeper understanding of how time shapes our reality. The question remains, if the future has already happened, what does that mean for our present choices and our sense of free will? We are reminded of the profound and enigmatic nature of time. It challenges us to think beyond our immediate experience. As we continue to explore and unravel the mysteries of time, we may find that the answers lie not just in the future, but in our ongoing journey through the present.